everyone. We're going to start our education now. We have Rob Mortko is here from Kansas City Master Gardeners, and he's going to be speaking about drip irrigation, a greener approach to watering. Rob has been a Johnson County Extension Master Gardener since 1999 and has served on its advisory board. Having retired from an engineering career in corporate America, he now pursues his own plant tissue culture business in Olathe. Rob's passion for gardening includes shade gardening, roses, and even turf grass. He has served on the executive board of the American Hosta Society, on the board of the American Hosta Growers Association, and as a contributing editor for the Hosta Journal. He is currently president of the Midwest region of Hosta Society. Welcome, Rob.
Cool. Can you hear me okay? Reasonably well? All right. Well, thank you. Thank you for the invite. Why do you think we should even waste our time talking about drip irrigation? All you got to do is look outside, right? Now, my clicker's not working. That's all right. I can do it this way. That's not working either.
We are not in the presentation yet. So
Oh.
got to click on the presentation.
There we go. Here's why we might want to think about talking about drip irrigation and maybe a little bit more efficient way of watering. We're in the middle of a drought. Doesn't it seem like drought years seem to become more the norm rather than the exception in recent times? Maybe I'm just turning into an old grumpy gardener, but isn't gardening more fun when Mother Nature does her part of the job? So anything we can do to kind of help make the gardening experience a little easier, I think is at least worth considering. The other thing about, our weather patterns, they seem to be becoming more and more erratic. We can talk about climate change and all this stuff, but wouldn't you all agree that our weather is becoming more erratic and it seems becoming more dominated by the extremes, right? We get no rain and then we get a 6-inch gully washer and it all runs off and it really doesn't percolate down into the soil. So it kind of skews the averages so that the averages don't even seem to mean so much anymore. And this was yesterday's data from the Kansas City Star. We have 3 airports in Kansas City and they report rainfall at each of the airports. Look at the variation in rainfall. Johnson County Executive Airport is real close to my house. That's the one I look at. We're about 13 inches below average for the year. Up at KCI, they're actually closer to average. So even when we get rainfall, it tends to be spotty, right? So you can look at the county average, and it doesn't really make any difference if that's not what's happening in your own backyard. And so that's kind of the background of what we're going to talk about today. And surprise, surprise, I had to get my Jayhawk in here. Okay. Rock chalk, baby. Like you guys, I do my volunteer work for K-State Extension, but I'm a proud alum from the House of Larned. So drip irrigation really is where engineering meets horticulture. Okay, and I'm going to share some things today that maybe kind of benefit from my background in engineering to really help better explain not only how drip irrigation works, but how you can implement it effectively in your own garden. What's drip irrigation is pretty much just what it sounds like, right? We're going to apply water pretty much on a drip by drip basis, on a very precise basis, directly to the root zone, and ideally not beyond that root zone. Okay. And as a result, it becomes a very efficient way of watering. I bet a lot of you have sprinkler systems at home. You spray that water up in the air. You goes where you want it to go. But the efficiency of most sprinkler systems are roughly about 50%. Okay, we get windage, we get evaporation. With drip irrigation, we're putting it right to the base of the plant and not beyond it, and we're upwards of 90% efficient. So a lot more efficient way of delivering water to the plant. So like I said, we're not going to waste water where it's not really needed. There's some other upsides with plant growth considerations. We're going to keep the plant foliage dry. So any fungal, concerns, we're going to minimize those. We're hopefully going to completely eliminate any runoff. Okay, so we're going to use that water very efficiently. We're not shooting the water up in the air, so we're going to certainly reduce the amount of windage. Never can completely eliminate evaporation, but we're putting it on a very precise area, so we're going to minimize that evaporation effect as well. We're going to minimize weeds because we're not putting that water where we don't need it, right? Where there's weeds would otherwise tend to take hold. And the bottom line is we're only going to save water, but we'll save you money. We're going to reduce your water bill as well. Questions? I am talking about a single emitter, not a soaker hose. I'll talk about soaker. I can talk about soaker hoses real quickly. They're very erratic in how they deliver water. Maybe if you're on a completely flat surface, but if you've got just a little bit of slope, you'll see a lot of difference in how much water you get, at the low end versus the high end. And then you'll also see a lot of variation in how much water gets delivered from the source end versus the end of the line. You can loop it and do some things like that to help. But no, we're talking about drip emitters, okay? Hopefully become a little bit clearer as we move on. So real simplistic view, maybe this answers your question right there. We're going to use one or more emitters on a plant. And we'll top out what kind of plants are candidates for this. And ideally, we're going to put that water right down to the root zone and not beyond, okay? Take a wild guess where drip irrigation originated. In the deserts in the Middle East. And the original concept was pretty simple. You just take a clay pot, unglazed, and that clay is very porous. Fill it with water, put it at the base of the plant, and you let it slowly drip to the root zone of a plant. And pretty simple concept. And that's the way drip irrigation kind of worked up until around the 1950s when plastic pipe manufacturing was invented, which kind of revolutionized the whole irrigation industry, including drip irrigation. There's some other terms you might hear applied to drip irrigation, but it's all the same. All right, we're talking about drip irrigation, micro, trickle, low volume irrigation. It's all the same. Let's talk a little bit about the factors that influence drip irrigation as applied to our gardens. Talk a little bit about both the soil and our climate. The type of soil we have has a lot to do with its moisture holding capacity and how water moves both vertically, called percolation, and horizontally. We always think about water moving horizontally through the soil, but that's a big factor that comes into play when we're designing our drip irrigation systems. Climate is the obvious thing that affects things. In Kansas, we have typically hot summers. Do we have wind? If I could change one thing about our weather sometimes, it would be the wind. Humidity comes into play, and then obviously rainfall when we get it, but it typically comes in our climate in the spring and the fall, not necessarily in the hot summer months when the plants need it most. With the exception of some of our native plants, irrigation is really essential for most plants that we're going to be growing in our gardens. And we know from our Master Gardener training that really the secret to watering optimally is that deep, more infrequent watering, not the daily, shallow watering. so that we can really encourage those roots to grow deeper. Water will move at different rates depending on the type of soil we got. And I think we inherently all know this, right? If you got sand, when you put water through sand, it's just going to go straight down drain very quickly. And at the other extreme, most of you guys have clay? This is starting, unless you live over by the river, maybe. Yeah, I mean, good news, bad news about clay is it holds moisture really good, but then it doesn't drain worth a darn. And so if you look at through these soil percolation tests, you can see how much water will percolate through roughly to 6 to 8 inches deep, which is where a lot of the root zone is at. So on one extreme, a half an inch of water in 30 minutes for sand, and at the other extreme, it takes about 5 inches for an inch of water to percolate through clay. Right? So if we kind of put that all on an equivalent basis, about an inch of water for sand in an hour, and about 2/10 of an inch of water per hour for clay. All right. So I mean, you can quickly look at those numbers with our reference base for clay. For most of us, it doesn't take a whole lot of rainfall, and you're getting runoff, right? If you're getting more than 2/10 of an inch an hour of rain, a lot of that rain is wasted, right? Because it's just running off. All right, so keep this in the back of your mind as we move through this. We don't always think about water moving horizontally, but it does, and this is a really key factor in understanding drip irrigation, how to apply it. Sand, and by virtue of the fact it wants to drain real quick, doesn't necessarily spread horizontally. But clay, due to the fact that it drains slower, will spread out more. Okay. And you can test this. You can take a little jug of water and put a little hole in the bottom and on some bare ground. You can actually watch, over the course of a couple of hours, that water spread horizontally through the soil. Okay. Here's the basic overview of the various components that you'll deal with in a drip irrigation system. I have to admit, when I put my first system in, I believe it was 1980, long before the days of internet and easy information, right? I had Joe engineer here from KU has to admit he was kind of confused about how all these different components fit together. Okay, but bottom line is it's not rocket science at all. We'll step through these components all the way from our water supply to the other end of the equation with the emitters. We'll step through these one by one. There's different ways to get at the water supply. A lot of these systems are set up very simple, where you're just going to hook them up to hose bib connection on your house. Okay. Totally manual, right? You turn it on and off when you turn the water on, but you can get fancy. You can automate this, even to the extreme of making this one of your zones in your sprinkler system. Okay. You're usually going to have a backflow preventer. Usually most of your local city and county health codes will require that, so you'll get backflow from the system into your house potable water system. A key is having a good filtration system. The passages on these emitters are very, very fine. They're pretty easy to plug up if you get debris in the system. One of the keys about drip irrigation, what makes it very amenable for a kind of a do-it-yourself project, it operates at pretty low pressure. So we're going to have a pressure reducer. I bet most of your house, if you ever check your water pressure, probably 60, 70, 80 PSI, something like that is typical. We're going to reduce that pressure way down to about 20 to 30 PSI by virtue of a pressure regulator. And you'll notice all of the threaded connections at this point in time, no matter what manufacturer you get or use for your drip irrigation, are going to be hose threaded connections. Okay, so they easily connect. The whole concept is to hook up to that hose bib connection on your home. Now, I mentioned you can do different degrees of automation. Like I said, you can do completely manual, which is fine. That'll work. It's the pressure's on you to go out there on whatever regular basis to turn it on, and then more importantly, to not forget to turn it back off. They make relatively simple, usually battery operated timers that you can hook up to your hose connection. That kind of give you some degree of automation. The key here is to make sure to look at the specs on that timer to make sure they'll handle relatively low water volume rates. Okay, with sprinklers, we're talking GPM, gallons per minute. With drip irrigation, we're talking GPH, gallons per hour. So much smaller volumes. Just make sure that timer will handle smaller volumes. But then we mentioned if you want to take it to the extreme, it just becomes another zone on your sprinkler system with its own separate, one or more solenoid valves that will turn on, one or more drip irrigation zones in your garden. Let's talk a little bit how you get the water to the drip irrigation system. You start with the main header. It's a polyethylene, fairly thin wall system because we're not talking high pressures. Typically about a half inch header, polyethylene pipe. That half inch will generally handle about 240 gallons per hour, which maybe doesn't sound like a lot, but a lot of these emitter buttons that we're using are about a half a gallon per hour. So that's a lot of drip emitters that'll handle. And 200 feet may not sound like a lot, but you can tee it and go in different directions and handle it that way. You can get the header with pre-installed emitters. This may be handy if you're using it like in more of a growing row crops, in a garden. Generally though, you're going to be installing those emitters at your own convenience. And all these connections with this poly tubing, the half inch tubing, are going to use compression fittings that just kind of force them together. At the other end, where we come off of that main header, we're going to use typically 1/4 inch laterals. You can find this 1/4 inch tubing in polyethylene, which is pretty rigid and hard to work with. I recommend looking for the vinyl, which is really flexible and easy to work with. Even the 1/4 inch vinyl will handle about 30 gallons per hour, which is a lot of emitters. So you can actually daisy chain them if that's more convenient for you. And instead of using compression fittings, they use barb fittings. I'll show you pictures of these. So there's typically the compression fittings. If you ever work with pipe, whether it's PVC or metal pipe, basically any kind of fitting you find with PVC or metal pipe, you can find with for drip irrigation systems. Couplings, tees, elbows. It's full range of options. Okay, and you can see those are those compression fittings where you just kind of force that pipe in there. Sometimes it takes a little bit of work, particularly if you're working in cooler weather. A little bit of heat helps soften up that pipe a lot and makes it a little easier to insert. How do you close the end of the pipe? A couple of options there. Most common is just what they call the figure 8, where you take that pipe, bend it back on itself, and that's enough since we're to close off that pipe to keep it from leaking. And it's also handy because we're going to talk about back flushing the system from time to time. So it's good to have an enclosure that you can easily open up and kind of flush the system out, particularly on startup. We'll talk about that. How do you go from half inch to 1/4 inch? These barbed connectors to actually insert into the half inch tubing. They make fancy hole punches, but in a pinch, I use ice picks and whatnot. You can, whatever is easy, just make sure you don't go all the way through the other end of the pipe, which I've done before if you're not careful. But you just use that barb connector to insert into the 1/2 inch, and then you go from there with your 1/4 inch vinyl tubing. It makes sense so far? It's pretty straightforward. You screw up or you change your mind, you know, we're always changing our gardeners around. No problem. They make these little goof plugs that you can just insert in there. And nobody knows the difference. Spend a lot of time talking about button emitters because this is really kind of the key where everything happens. Typically 1 emitter per plant, although, you know, we can talk about bigger plants, even small trees as they're getting established, you might use more than 1 emitter. This is where the confusion gets into play with drip irrigation. It's like, okay, these emitters come from usually in 1/2 inch, or excuse me, 0.5 increments of gallons per hour, but starting at a 1/2 gallon an hour and going all the way up to 2 gallons an hour. You say, well, gosh, bigger is better, right? 2 gallons an hour, you know, not necessarily. We're going to spend some time talking about that. And I'll show you why usually 1/2 gallon per hour emitter is your best bet for most soil situations. And spacing them about 24 inches apart is going to be your best bet for. And I'm using loam as a reference, not because we're starting with loam, because that's ultimately what we try to create in our garden, right? With doing various amendments. But then to further complicate things, these emitters come in different types and styles, you know, from inline to pressure compensating, blah, blah, blah. So we're going to spend a little bit of time talking about that. You're going to install all of this on top of the soil. Now, do you mulch your beds or don't you? I can tell you after, you know, about 30 years of having drip irrigation in a rose garden and mulching for 30 years, what does that mulch do? Breaks down. So that system starts off at soil level. What happens over a period of time? Kind of sinks down. And so there is a little bit of maintenance that we need to do. So the key is really, I don't care where, if the 1/2 inch main ends up being settling a little bit in the soil, but you want those button emitters still up above where you can kind of every so often visually see them to make sure they're still dripping and that they're not plugged. All right. Not so good to find out they're plugged because the plant died because it didn't get any water, right? So pros and cons about mulching with drip irrigation. 2 basic types of these button emitters, the end of the line and then the flowing through. It just depends on your situation, all right? You don't have to, if you've got a series of plants over here and your main lines over here, you don't have to go back to the main line for each plant. You can, like I said, you can use these end lines and daisy chain them, all right? But then the other issue has to do with, you'll see non-pressure compensating emitters and pressure compensating emitters, okay? And the problem with using these non-pressure compensating emitters is you'll get a fairly wide range of flows. You might have 0.5 GPH, nominal GPH, but you can see the range of flows over a series of pressures. And even though you have that pressure reducer up front that sets a certain pressure, that pressure is going to vary over the length of the tubing, right? So you can get, you know, 50 to 70% variation flow when you're using these non-pressure compensating emitters. Doesn't mean they won't work, but if you're striving for ultimate efficiency, I'll put in my pitch for using these pressure compensating emitters. And I'll show you some prices later on. They're a little bit more expensive, but not that bad. But you can see they hold their flow over that nominal range pretty consistently over a wide range of pressures. Okay. All right, so I would get back to this soil structure and horizontal movement of water, because this is going to kind of become a key in our understanding of how we design our drip irrigation system. Okay. So this gets into the part that they don't tell you any of the drip irrigation manufacturers and their informational materials that they provide. Because our background as gardeners, we think of rainfall as Mother Nature provides it. You know, a uniform application of water over the complete garden. But with drip irrigation, that's not how it works, right? It's kind of a point source. All right, so if I use, let's say, that half a gallon per hour emitter, how do I make sense of that in terms of equating it to what my reference point is? I say, I know a certain plant needs so many inches of water a week, right? So how do I equate all that? Well, it's not as complicated as it sounds, but we go back to, okay, how is that water really spreading in the type of soil we have? And I'm going to use loam as our reference point, but you can apply this to any type of soil from sand to clay. And remember, we showed that in a loamy soil that we get about 24 inches of horizontal movement. Okay, so that's where we're spreading that water out. And just a little bit of math, you know, 24-inch, we're just going to calculate the area of that circle. All right. So remember pi d squared over 4. All right. So this is an easy one. So the area ends up equaling pi, right? Which is 3.14 square feet. Okay, so we're going to, an example, we're going to take 1 gallon of water with a loamy soil, and we're going to very slowly apply that, maybe not drip by drip, but we're going to apply it slowly enough that we don't get any runoff. Okay, and we're going to convert that 1 gallon of water into cubic feet, and we're going to calculate what the equivalent rainfall is for that. So convert it into terms that maybe we can understand better as gardeners. And so the equivalent rainfall of that 1 gallon is about 1/2 inch of equivalent rain. Okay, are you with me? You're not? Okay.
Oh, there would be no math.
Go and invite a KU engineer then. All right. So, I got a pointer, laser pointer here somewhere. Yeah, it doesn't matter. So that 1 gallon an hour that we just illustrated in loamy soil, that 0.5, you see that in the middle? Okay. You can do that for any combination of soil type. But then also remember those percolation numbers that I showed you early on about how much water you can apply before you get runoff. So here's the key, and this is what they don't tell you in any of these drip irrigation brochures. Our goal is to not exceed the amount of water that the soil can take. Can you see that a lot of those choices that you have, you know, again, I said earlier on, you know, you might think more is better. Those 2 gallon an hour emitters are pretty much going to, across the board, exceed what the soil can soak up, and you're going to get runoff. Okay. So my earlier comment about how 1/2 gallon an hour or even 1 gallon an hour emitters in most cases are going to take care of any type of soil structure that you might have. Okay, you're going to be at or less than what the soil can absorb. Okay, that makes sense? Because like I said, that's the key part that they don't tell you in any of these brochures. And from there, you can use those numbers for equivalent rainfall to say, okay, let's go back to that 0.5 with a 1 gallon an hour emitter. So I'm getting the equivalent of 1/2 inch of water if I go for an hour. So how many times a week might I cycle that on? I want to shoot for 1 inch of water a week. There you go, a couple times a week, right? Do that, more math, sorry. Um, drip irrigation is very much a do-it-yourself kind of a project, with maybe one slight qualifier. If you're going to hook it up to your sprinkler system and you have to install another valve, maybe you need a sprinkler guy come out and do that for you. But the actual installation of the downstream equipment is very much a do-it-yourself project, and it's easy to install. It's not like PVC where you're going to have to use glue, and you really don't need any specialty tools. The components are pretty easy to find anymore. You can find it at most of the box stores. You can certainly find it very easily online. One caveat I've learned: you go to the box stores late in the season, like now, you're starting to see those get moved out and they got Christmas stuff in there already. It's kind of considered a seasonal item in a lot of places. There's installation guidelines you can get from most manufacturers. You can find those online easily. And if you're completely new to all this, you can get these kits that'll get you started. It may include stuff you don't need and may not include everything you do need, but at least kind of get your feet wet and get you started. So where can you use drip in the home landscape? It's pretty much anywhere and everywhere. The obvious things from the shrubs, the rose gardens, your annual perennial beds. If you got vegetable gardens, they actually make, I didn't mention so much, but they make drip tape with those pre-installed emitter heads already in there. Some really handy things if you've got a lot of containers, plants and containers on the deck. I mean, that can be kind of a pain to get out there and water at least once a day, maybe sometimes twice a day. When it's really hot and dry, gosh, drip really simplifies that. I use it for things like filling up the fountain. And even I got a whiskey barrel with the water lily in it, and use it to make up the water to the whiskey barrel every day. All right. And hanging baskets, which can be kind of a pain to water sometimes too. It's just a matter of tacking that 1/4-inch tubing up the wall and into the hanging basket. So no shortage of options in how you can apply this in your home landscape. It's always good to start out with a plan. You're going to figure out how this is all going to work, and then what do you really need in terms of number of heads and how many feet of pipe you need and everything. This is a pretty elaborate system, I must say, with multiple zones. A lot of times you're not probably going to have more than one zone. In my own garden, I have everything on one zone, and I try to adjust how much water different kinds of plants need by picking different. I might use a 1/2 gallon an hour emitter here and a 1 gallon an hour emitter over here. And this is a small tree that I'm trying to get established. I might use 2 or 3 there. But start off with a little hand-drawn sketch about what you're trying to cover. Maybe do some measurements out in the garden to give you some idea of how many feet of piping you need, and you can go from there. Okay. These prices might be a couple of years old, but it gives you some idea of kind of what it might cost to put in a system. None of this stuff is terribly expensive. Okay, for a couple, $100, $200, you can be well on your way to having a drip irrigation system in your garden. The priciest part might be as if you integrate it in with your sprinkler system, the cost of the solenoid valve, and maybe having a guy come out to install that portion of the system might cost a little bit more. The controller itself, particularly if you have a dedicated one just for your irrigation system or your drip irrigation system. I mentioned earlier the different type of emitters. You can see the price difference on the pressure compensating versus the non-pressure compensating. There's a little premium you pay for the pressure compensating, but it's not huge. In my mind, it's well worth the cost to try to maintain a very even water supply.
How frequently do you consider either swapping out or checking the filter?
I'm going to get to maintenance in a second, but we'll hold that question just for general maintenance system. But again, not an expensive project, and very much again a do-it-yourself kind of project. A couple of tips I've learned kind of the hard way. Be careful when you're laying out that 1/2-inch tubing. Last thing you want to do is kink it. It's fairly thin wall, particularly in colder conditions. It's really easy to kink, so you kind of want to unroll it. Helps a lot if you just let it sit out, that black hose, set it out in the sun, let it soften up a little bit before you apply it. Take some just metal hangers and cut them into pieces and bend them and use those to kind of stake the header down, keep it in place. And you can use the same thing. I do a lot for the 1/4-inch emitters. All right, keep them in place at the base of the plant. Key thing when you're installing the system is the last thing you want to do is install the emitters. Put in your 1/2-inch, put in your 1/4-inch laterals, get your water supply hooked up, and flush the system. All right, you'd be surprised what little bit of debris it takes, and you're invariably going to get a little bit of soil, whatever, in that pipe when you're installing it, and that debris will clog the emitters. Generally at the far end, because it'll push it all the way through until it finds that last emitter on the system, and then it will plug that. Okay. So, like I said, you're going to open up the enclosure, whatever type of enclosure you have, and you're going to flush the whole system before installing the emitters. And we talked a little bit about, the duration and the frequency just depends on, what kind of plant you're covering. Is it a vegetable or is it a small tree? All right. And then obviously factor in, is Mother Nature helping or not, right? If you use a sprinkler system controller, a lot of these newer sprinkler system controllers will actually have an internet interface and they go online and find out what your evapotranspiration rates are in your area and adjust watering accordingly. Okay. And then when all else fails, just trial and error. Like I said, and you can also go online yourself and find out what ET rates are. K-State has a site, and for the state, and you can pick a site that's nearby your gardening location to get an idea of how much water. This factors in evaporation and windage and how much water is actually being consumed by the plant. And I'll tell you in total, and it factors in any rainfall. Give you an equivalent loss or gain of water in the soil. And it's interesting if you go online and look at the data. It's amazing because in my mind, a lot of, let's just take turf for example, an old rule of thumb: 1 inch of water a week, right? We've had some summers where it's really hot and dry where we're losing about 1/2 inch of water a day. So a lot of times we have problems growing plants. It's, well, I've been out there watering, I gave it my 1 inch of water a week, but you're losing the equivalent of 1/2 inch a day, and stuff's still dying, or it's just barely hanging on. There's your answer, right? All right, back to maintenance. I like to check my filter screen when I start the system up in the spring. Generally, with city water, you're not gonna collect a whole lot of debris in that filter. But again, it's important making sure you're not clogging up any downstream emitter buttons. If you're on well water, probably a different story. You may even want to check it more often, depending on what you find in that filter screen. I wouldn't overall say drip irrigation is a very maintenance intensive system, but things will happen. Every so often you'll find a emitter that's come loose. What I like to do is just periodically go out there and walk the garden when the drip irrigation system is operating. If you hear a hissing sound, it'll give you an audible indication. If you hear a hissing sound of some sort, just go figure out where it's coming from. Every so often, and particularly if we have a really hot, dry summer, we'll have squirrels get in there and, rather than just drink out of the emitter, they'll just chew off the 1/4-inch tubing. Get a drink that way. But again, you'll have an audible notice that something is awry. And, it's easy to fix. But you just need to get out there and be aware. Just like sprinkler systems, you're going to want to drain it for the winter. One thing I didn't mention, but I like to use kind of the equivalent of those enclosures, particularly that little figure-8 thing I showed you. I put one, particularly if you got any slope in your yard at all. Go to the low point in your yard and just install one. I just use 1/4-inch tubing and I'll bend it, just use some wire and make a little figure-8 out of some wire. And I'll just open that up during the winter. Okay, so you get drainage so you don't have water sitting in the system during the winter months. What you don't want to do, those of you have sprinkler systems and you either do it yourself or you have a contractor come out and air blow the system. You do not want to blow compressed air through your drip irrigation system. Okay. That will definitely cause those emitter heads to blow off. That's it. You're all experts now. All right, lots of questions. Let's start up front here.
Putting in your pots.
Mhm.
How do you make that look nice?
When I did it on our deck, I would just bring that 1/4 inch. Usually there's enough gap between the boards on your deck, your 2x on your deck. I'd bring that up through on the backside, bring that 1/4-inch tubing up through the gap in the boards, and then
So you just have to.
just a tiny tube. Want to be fancy, you can spray paint them colors. Taking it up the side of the house, that black wall, the black tubing on say a white wall, just paint it. I mean, you can hide it real easy. Yeah. Yes, ma'am.
With the hard water that we tend to have, we don't get any classification in those.
I mean, I have hard water too, and I've never really had plugging as a result of that. Yeah. We've got to go further to back. So
I mean, still confused as far as, I assume the filter and all that need to attach to the faucet. And then if you're going through a grassy area, what's going through there before you get to the garden or something?
So you generally, your filter is going to be upstream of everything and located in an accessible area. So if you're like that picture I showed you earlier, if you're coming right off the hose bib, it's going to be right there next to your valve, so you can access it easily. But from there, you're just flowing through your 1/2-inch main pipe until wherever you get to where you need to be.
So do you have to dig that under?
You can dig it under, and I just take a flat edge spade and just spread the soil just a little bit and tuck it down in there. I try to get it 3-4 inches down, so if I ever core aerate the lawn, I'm not hitting that. So get down deep enough where that's not going to be an issue longer term. Yeah. Yes, ma'am.
So the drainage, put in my first system this spring, and I don't have like a low place in my yard. So is it literally lifting it at certain places?
No. I don't want to make too big a deal of draining it for winter, because just if you got PVC pipe like you have in sprinkler system that's rigid, this stuff's pretty flexible and pretty forgiving. So, you know, if you have a little bit of remnant of water in there and it freezes, it's gonna expand probably enough that it's not gonna break that half inch or even the quarter inch tubing. But if you've got an easy way to put in a low point joint, that's just, you know, all the better. In terms of avoiding any potential issue. Yes, sir.
Vinyl polyethylene. Is it an either or, can you mix them?
Well, a quarter inch. You can mix them. Like I said, in the quarter inch, that can be pretty hard for me to get those barb fittings to work in the polyethylene. It's just a lot more rigid. And that the vinyl is just so much easier to work with. You can bend it around. You don't have to use elbows and whatnot to get it to where you want to go. It's just easier to do. One thing I forgot to mention earlier, and there are lots of different brands that you can use, and you can mix and match brands with one caveat. On the half-inch stuff, those compression fittings have to do with the ID versus the OD, the inner diameter and the outer diameter, and those can vary from manufacturer to manufacturer. So try to stay with one manufacturer on the half-inch stuff. You can mix and match on the quarter-inch stuff. It'll all work. Okay. Yeah.
Horizontal, figure 1 foot on each side. If you've got an emitter, you figure what's 24 inches, foot on each side.
Yeah. And I didn't mention this either. I mean, there's no shortage of plants that you can use this on, but is drip irrigation going to be your most effective approach on a mature tree? But a young tree, you know, that 5-gallon pot or that ball of burlap when you first plant it, my God, with the way our weather is lately, that's kind of the key to getting it established, right? Is regular water in that more immediate root zone. But it's longer term, that's probably not your answer for as trees mature. Okay. Yes, ma'am. I like, you've heard of rainbird for irrigation. They have the equivalent rain drip for their drip line. It's easy to find. I like them. But you know, that's what I like, but I'm not necessarily endorsing them. They'll all work. Work my way back. Yes, ma'am.
Put it on top of mulch, don't mulch over.
Yeah, you know, the sun really doesn't. Usually most of this plastic material is UV stabilized, so you're not going to get, it's not going to become increasingly brittle. I've just, for example, in my rose garden where I installed this almost 30 years ago, and I had mulched year after year after year, and gosh, I went to replace some of my emitters, and I had to dig down to actually find the half-inch so I could find the quarter-inch, and it had sunk down quite a bit. Roots of the roses growing on top. Anyway, I just want you to be aware of, you know, the long-term effects of mulching, and you know, if there was an easy way to kind of lift that, I know, and I understand that half-inch main sitting on top of your bed is maybe not the most aesthetic thing. We'd all kind of like to hide it, just like we want to hide the tubing on, you know, getting it to the containers on our deck. But for sure, just make sure that you have visual access to the emitter heads, because that's generally where, if you have problems, that's where the problems are going to be, and particularly at the end of the line. I always find that almost every year in my rose garden, the emitter that's at the very end, it plugs up. So I just, you know, when I'm out there checking my filter in the spring, starting things up, I just almost always go and look and see if I'm getting any flow out of that last emitter, and generally I'm not, so I'll just change it out.
Rob, we've got a couple questions online.
Okay. And by the way, once an emitter plugs, there's no turning back. I mean, you can't fix it. Right? You can't blow them out or anything. They've got multiple passages in there that are real fine. You just got to replace them.
Okay, and if you can repeat the question when she'll give it to you, but you
Sure.
can repeat it so that Zoom people can hear it too.
Can we just keep the house water at a low flow to reduce pressure?
Can you, I think the essence of the question is, can we get by without using a pressure reducer or pressure regulator by just reducing the water from the valve and trying to reduce the flow that way? I suppose you could. Just realize, if you set that, turn the hose big valve so you're kind of getting a trickle, and then you go inside and take a shower. That's going to affect water pressure through the whole house. So I'm not saying you can't do that, but those, if you saw the pricing on those pressure reducers, it's very nominal. I would probably personally wouldn't mess with trying to do it any other way.
Can you build a system starting with the main line of PVC pipe?
You can, you just gonna, can you start a system using PVC pipe? And I suppose you can. I'm not 100% sure why you'd want to.
Because the system's already in
Because
place.
it's, well, it has. And in essence, that's what you're doing if you're tying it in on your sprinkler system anyway. You're gonna have to branch off that PVC. And in my example, you're having a solenoid valve, just like you're going to any irrigation. So I mean, that in essence is what you're doing. Anyway, but at some point you gotta transition from the PVC pipe to the drip, right? So, yeah, you can certainly do that.
Go back to.
All right. Yes, ma'am. I know. We're gonna have to start from the back and work forward. You're quite welcome. I think anything would benefit getting them established in the current situation with our weather. Now, I'm not an expert on natives, but I mean, obviously the whole allure of growing natives is that, they need less water. They're going to be very deeply rooted, but you got to get the roots down there to start with. So I wouldn't hesitate to say it's certainly going to benefit early on for sure. No, you're not gonna do one. No, when you get in and they have special system with those emitters pre-installed, and they're gonna be spaced, and you can pick it based on your soil type, but you can get this tape basically with those emitters every 24 inches. So it's not gonna be, let's say you got carrots and they're spaced every 6 inches, three or 4 inches, whatever. Yeah, you're not gonna have emitters every 2 inches or anything like that. You're gonna rely on that horizontal movement of the water through the soil, and they'll be spaced, that same kind of 24 inches. Yes, sir.
I probably would not look at it. But the question is there any kind of winterization process I would need to go through on my own to take care of it?
Like I say, they're pretty forgiving just by nature of the fact that both the 1/2 inch and the 1/4 inch are pretty flexible. I like to drain them as best as I can. You're not going to get every drip of, every drop of water out of the system, but they're pretty forgiving. Like I said, don't try to air blow them. But if you do have a low point, kind of put in a low point drain that you can manually open up and just kind of drain the bulk of the water from that 1/2 inch header out before it gets cold, and then Remember to close it back up in the spring when you turn the system back. I've done that before. Right, it's all about efficiency, and sometimes we can shoot ourselves in the foot when we forget. Yeah, exactly, exactly. Okay, we had some questions. Yes, sir.
Just a comparison, Wittenberg also makes a vinyl hose with drips every 18 inches. That's what we have in our yard. It's not specific to individual plants, but
Right.
it's all a big circle.
Sure, sure.
Thoughts on that?
No, I mean, I don't want to split hairs here. I mean, this is all about efficiency. So I try to play up the fact how we can make it as efficient as possible. But, you know, at the end of the day, whether you use 18-inch spacing or 24-inch spacing, you're still miles ahead of what you'd have with either hand watering or using kind of a sprinkler, you know, spray the water in the air to try to water the garden. You're still way ahead of the game. Yeah. Yes, sir.
In terms of the emitters, what's your theories on the regular button emitter versus the bubble?
Yeah. There are lots of other kinds of emitter heads that you can find. A lot of them approaching what you'd find with regular sprinkler systems, you know, sprayers and whatnot. Kind of mixed emotions about that. It depends on your specific application of what you're trying to accomplish, right? But in terms of efficiency, you're probably moving farther away from the super efficient. Anytime you spray water up in the air, for example, I mean, you're just going to lose efficiency. It's just kind of the nature of the beast. But like I say, you can find those on the market as well. It's not just button emitters to get the water out to the plant. There's little sprays. And like I said, there's all kinds of things that kind of very, very similar to what you'd see with a conventional sprinkler system. So, yeah, it's not that you can't use them. Again, it's just kind of an argument on efficiency. Yes, ma'am. Yeah, you could. Sure. Yeah, if you got an existing hose with emitters, yeah, you can add more. Yeah, that's easy. It shouldn't. I mean, like I said, you're not, it depends on what those other emitters were and sizing and everything. That would be helpful to know, to make sure you're putting in comparable sized emitters so you're not getting more flow here than there. But yeah, you could certainly do that. Yeah. Right. Right. Yeah. Yeah. I don't have a vegetable garden, so I've never used those ones where they're pre-installed at regular intervals, but if you got the right situation, those can be really handy. Like I said, the problem with gardening is we change things, we change our mind, we move plants around, and where we needed an emitter, we don't have one, or where we had one, we don't need it anymore. So flexibility is kind of the name of the game. Yes, ma'am. You need, yeah, the question is, can you hook them to a rain barrel? You need pressure. I mean, don't need much, 20 PSI. So you would need kind of a pump of some sort to do that, to give you some nominal pressure to drive that. Yeah. Yes, ma'am.
Is there anything to discourage squirrels?
Is there anything to discourage squirrels? A BB gun. Sad to say. Yeah. If there is, I haven't found it. Right. I mean, you know, cayenne pepper, suppose like birdseed, you can put cayenne pepper, that kind of discourages them, but nothing specific to the drip irrigation system that's necessarily going to discourage. And don't get me wrong, maybe once in 30 years I've had a squirrel. I actually saw the thing chewing on a drip. It's not going to happen every day. It's not that big a deal. Yeah. No. No, I used to run a nursery and gosh. I'd have to go out this time of year, I'd have to go out there and check the nursery, the greenhouse twice a day because when the walnuts start falling, they want to pop the plant out of the pot and bury their walnut. Not only do you lose the plant, but then next spring you have all these walnuts popping up in your pots in the nursery, and generally customers didn't want to buy walnut trees.
We're about done.
Okay, thank you.